Okay, time for our Chapter 3 study guide. And Chapter 3 is all about linear regression. These are going to be our scatter plot problems with our lines of best fits. Now, future students, you guys will already know that Chapter 3 ties in with Chapter 12, and we kind of reviewed Chapter 3 already when we got to Chapter 12. So this should be a little bit familiar. For my 2020 kids, though, we have not covered Chapter 12. So instead, this will be going way back and talking about all those scripts and all those different things you had to be able to interpret when it came to linear regression. So this is probably our most script heavy chapter that we talked about. And I give you in this study guide here a spot to write down what all of those are. So make sure you have those written down and they come back to you because it's been a bit since we've talked about them. All right, so jumping in with some multiple choice right here, we have a linear regression equation, and instead of using the y and the x, they're using the variable names as the words right there. Instead of writing predicted calories, if you wanted to go with y and x, make sure you always make your y variable with a hat on it, or you could just write the word predicted like they did right there. So always a hat on your predicted, and then you could have your x over here, but you would need to make sure, if this was a free response question, always define your variables when you do these. So anyway, they just ask you which of these statements is false. So we're kind of going through them and just looking at them and seeing which one looks good and which one doesn't. A is basically your interpretation for the slope. For every 1 unit increase in x, which in this problem is the fats, the y is predicted to increase by about, and our slope on this problem is 9.6, which they call 10, which is fine. I don't like the way they word these choices here. They said estimated instead. I like predicted better, and I like to put it at the end of the statement, but you need to make sure anytime you're talking about linear regression in these kind of contexts and interpreting stuff, it is the predicted amount, not the actual amount, and you will lose credit on rubrics if you don't say that. So anyway, long story short, A is cool. It's basically they rounded it to 10, but that's saying what it's supposed to say. B is asking for or giving an interpretation for the y-intercept, which is when there is 0 of x, so no fats. The predicted y value, predicted number of calories, is supposed to be about the 97 right there, which is plausible, so that's totally good. C, if a cereal has 2 grams of fat, then it's estimated the total calories is around 216. What you would do for that is just plug a 2 right in here and just type it in the calculator. Just plug in for x, see what you get. It is pretty close to 116, so that is going to be a true statement as well. D, the correlation between fat and calories is positive. You can tell that by looking at your slope. Positive slope means positive correlation, negative slope, negative correlation. So that is a true statement, meaning that E has to be the right answer. And just to review how you do that real fast, remember residual, you are going to take your actual y value minus your predicted y value. Residual is actual minus predicted. The 140 is the actual weight for that cereal. So you would take 140 right here. And then what you would do, actual calories, I said weights, the actual calories for the cereal. And you would need to subtract the predicted value. The way you would get that is by plugging in the x value that they give you. So you would plug in a 5 for fat in your equation. And then once you type it in, you would just see what you get. I believe you get a 145 if you plug it in. So the residual on this point is actually -5, not +5. They ask which statement is false. That's going to be E. All right, on to our second problem then. All but one of the statements contain an error. Which of these could be correct? And these are all talking about R. Important things to realize with R. First of all, it has to be between 2 quantitative variables, numbers. That's the first thing, because you see it on scatter plot problems only. Secondly, it has no units. And thirdly, it's between -1 and +1. If you can remember all 3 of those things, you should be in pretty good shape here. Choice A says correlation is 0.54 between a football player's position and their weight. Weight is a number, that's cool. Position is not. That's a categorical variable. You can't do R on that. Same issue on B, talking about gender versus political party preference. Those are actually both categorical, so that's a no. C tries giving R units. That's not allowed. R is just standardized kind of thing. D says the correlation is over 1, which is a really bad thing. Can't do that. It's always between -1, +1. And then finally, E takes two quantitative variables, moisture and then yield, and it gives an answer that is reasonable between -1 and +1. Correct answer on this guy is also E. All right, number 3 is talking about a residual plot. And a residual plot, if you guys remember what it does, it keeps your x variable the same. So the x that you see, which is height on this problem, is the same as the x variable from your original scatter plots. But what it does on your y, instead of taking your y variable, it instead graphs the residual of your y value. So it finds your residual, and that's what they graph vertically. So a positive point, residual being positive, means that the actual was bigger than what was predicted. And a negative means that the actual was smaller than the predicted. For a linear model to be appropriate, you need to see in your residual plot just a bunch of random scatter, points everywhere. Because what a residual plot does is it magnifies the difference in the predicted values, and it kind of like zooms in on it and changes your perspective, where if you just see scatter, it means your linear model is doing the best job it could. You very much see a curved pattern on this residual plot, and what that would tell us is that there's some sort of curved equation that can help us better account for our predictions and make a better job predicting, basically. So if you see a pattern that is no good, we do not want to see a pattern that would tell us the linear model is great. That is going to be basically what choice C is saying. Curved pattern suggests the linear model is not the most appropriate choice. So we got C on number 3. Going on to the 4th problem. The fancy name for a line of best fits is an LSRL, least squares regression line. And the reason for that, again, if I was going to draw my line of best fit right there, say I got myself a line. What you would do, we've seen these pictures where you had like the dots coming off and they drew in the residual, like you see in my sweet picture here. And they would basically square them. That way you didn't have negatives and positives washing each other out. Because if you just took all the residuals and added them, the negatives and positives would wipe each other away. What we do is we square them and we illustrate that graphically. It's that picture you've seen before with all these little squares on it. That is called the sum of the squared residuals is what we're looking at for that. The choice that says that is going to be C. It's the sum of the squared differences between observed and response variable of the response variable and the predicted of the response variable. That whole second sentence right here between the blah, 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 that just means residuals. Observed and predicted for the response variable is exactly what a residual is. They just said observed instead of actual. So it's the sum of the squared residuals, which is choice C. All right, these last 2 multiple choice questions are using that little table of computer output, which is a very popular choice on the AP test. They don't like to do linreg stuff on the calculator because it takes too long and it's too likely you punch in a number wrong and they can't see what you did to give you partial credit. So it's actually pretty popular for them to make little tables like this. So it's very key that you guys can read them. Constant is the y-intercept in your equation. So that guy right there is your y-intercept. And this is my x variable, height. So the number next to the x variable is your slope. So what this is saying is that your equation goes 28.174 plus 0.214 blah, 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 x. And when you write that out, you would naturally define x if this was a free response question. But this is your basic linear formula. Now, I like this question a lot for number 9, because what it does is it talks about, this circled point right up here. And it says that the roller coaster has a maximum height, which is our x variable, of 70. Okay? It asks for the observed speed. Observed is a synonym for like the actual speed. Now, what people will do on this question is they'll be like, the residual is like 11. They just look at it and they say 11 or 12, and that is totally an answer choice, choice A. But that's the residual. That's the difference between predicted and actual. That is not the actual observed speed. Okay? What you have to do to get the observed speed is you need to first of all figure out what would the predicted speed be. Because we know that residual is actual minus predicted, but we don't know what the prediction is supposed to be. That's why they fed us this 70 right here. So what you're going to do with this problem is you're going to plug in a 70 in place of where you see x. Okay, and if you do that and plug a 70 in, you get a 43 points, like 1 or 43.2, somewhere in that area. Okay, so that is my predicted 43.1. But they didn't ask for the predicted either, and that's a choice. So they had 12, which people would choose. They had 43, which people would choose. The observed is going to be, so if my residual is actual minus predicted, R equals A minus P. The symbol for residual is resid, but I didn't want to write that out. I already know my predicted is 43.1. And my 11 is written in an unfortunate position right there because that's actually my residual, which goes over here. I'm going to call it 12. I would need to figure out what A is. Basically, you just add 12 to your prediction. It's going to be 55, which is choice D. Good question, because there's a lot of places you can make a mistake and get tripped up. Final multiple choice question is asking about S. S is one of your scripts that you guys need to know, and it is the standard deviation of the residuals. So if you take all those little residuals, how far are you off the line above and below, and you take the average of those, they tell you typically, on average, how far off your predictions are going to be. Correct answer in terms of an actual script right here is E. It's the standard deviation of the residuals observed minus predicted. But I wish they would have interpreted it here. So actually, for this problem, what I have, let me see, I got a little bit smarter on this one, so you guys don't have to watch me like fumbling around in the keyboard for like 5 minutes, and I typed them up in white before I showed it to you all. So the script, which you guys already have somewhere, when using a linear model with X to predict Y, our predictions will be typically off by about blank. That's how you would interpret S. And you should already have that in your study guide portion above. Make sure you know those scripts. So that takes us to our free response question for this chapter. And this free response question is going to be one that makes us describe a scatter plot and look at some other things related to unusual points and outliers, which is good because it's a big part of this chapter. Looking at this first question here, they ask us to describe the association between price and quality rating for the sewing machines. So remember when you describe a scatter plot, the little acronym we had, or no, the little list we had to do was called FUDS, F-U-D-S. Form, unusual points. We're not calling them outliers anymore. We call them unusual points. Direction and strength. Form for this problem is talking about whether it's linear or nonlinear. And this graph, we usually use the word linear very liberally. Like, oh yeah, it's kind of linear. Looks like sort of a line. But this graph starts out really kind of crowded, and then it goes up, but it comes back down. There's that part where the points are higher in value right here, where we got a little curved action going on right there. So this data set does not appear to be linear. This would be a nonlinear data set. The overall direction of it, so I have form is nonlinear. Unusual points, I could address this one point right here. They make us do that actually in a later question in part B. That point could be considered unusual. They didn't actually make you do that on the answer key, but you should write it down anyway. So unusual points. Direction is talking about whether it's going to be a positive or a negative, and it does appear to be somewhat positive, especially throughout this whole part of the picture. So we have somewhat of a positive association. Strength is talking about how closely they follow a pattern. Is it very tight and strong, or is it a lot weaker? This is pretty weak. The last thing you would need to do with this problem is make sure you mention context. And again, instead of me sitting here for like 5 minutes typing, look at this. I have the answers that you guys can look at what I wrote for a nice, clean, full credit answer. So you had to address form, direction, strength, and you had to give context on this problem. Unusual points would have been good, but it was not in the rubric to get full credits. So that is a good answer that recaps what I just talked about. All right, second question says, one of the sewing machines substantially affects the appropriateness of a linear model for my problem. We have to say what machine it was, and we have to explain our choice. The rubric on this question was a little bit finicky. First of all, I hope you guys can all agree this guy right here is the unusual point. The coordinates for that are around like $2,200 and a rating of like 65 or something like that. Let me talk you through what you needed to do on this problem and why this point ruins our line of best fits, and then I'll tell you what you actually needed for a full credit answer. So the basic idea with this point right here, all my other points more or less follow, like I could have gotten by. If that point wasn't here, a linear model actually wouldn't have been too terrible, but this point throws off the trend. And the AP test starting in 2020 has made more of an emphasis on knowing your vocabulary with linear like points that are weird. So unusual points is like a vague throwaway, just very general term. We have outlier, we have a high leverage point, and we have influential points. They're all more vocab words that we can use to describe our scatter plot. The biggest issue with this dot over here, if I take my line of best fit like you guys already see, my line of best fit goes like this. This point has an x value that is way more than all the other points. A point on the edge like this is called a high leverage point because what it's going to do is it's going to take your line and it's going to grab it and it's going to tilt that line towards that point. So what I would expect to see in this problem is my line of best fit, which I have drawn in right now, would probably get more like this if I add, because of this point. Like if that point wasn't there, you'd see this line. But if you have this point in there, the line of best fit probably gets yanked more like that. And what that's going to do is just mess up the fit for all of those other points. If my high machine wasn't there, you have a roughly positive pattern going on, but this point actually messes up that correlation. And let's see, what else do I want to say about this? If you think about this on a practical level, like the rating on the machine can probably only go so high. There probably is like a maximum score you can get. Charging a lot more for the machine isn't going to magically make it a better machine. It's just an overpriced, terrible machine there. Not terrible, but not great either. So with all my wordiness there, this is a good answer that I typed up that would get full credit for this question. You identify the points and you talk about why it is not following the overall pattern, why it makes it a curved data set, and what it's going to do to the line of best fit. And the big thing is that it's going to pull the line towards it, which messes with the predictions for all the other points. So final question here, and they are asking, this one's a little bit of a brain bender. They say that this guy is interested in buying one of these 14 machines. He will only buy machines for which there is no other machine that has both a higher quality and lower price. So he's not going to buy the machine unless it's the best quality he can get for his money. Okay? So the best machine in this whole problem right here, we had to circle the points that he would actually buy. This machine, there is no machine that is better in terms of quality. That is the best machine out of all 14. So he's going to buy this machine, or this is one that he would be willing to buy because there's no machine with higher quality. All right. Then if you look at a dot like, I don't know, over here or something like that, that dot does have pretty good quality, but you can get that quality in a lower price. It's the dot that I already circled. So all of these dots over here that have like pretty good quality, if they're more expensive than the one I already circled, he's not going to buy them. He's not wasting his time buying those guys when he already picked the best machine. The other kind of qualifier on what he said is that if you can get good quality but for less price, that would also be okay. These machines right here are all lower quality, to be sure. But the one, and then this one maybe has a price that's a little bit better. But the other machine that's going to qualify for this pretty substantially is that guy right there. The quality is not as good as the first point that I circled, but it's one of the cheapest machines out there. So for the price, this guy is going to be good. And then I looked at this point, I was like, oh, should I circle this guy right there? But now that I have this second point circled, this is the next best machine. It's got a better quality than this one, and that guy's more expensive, so that would not count. So the only 2 points that fulfill his requirements of being the best quality for the money are the two that I have circled right there.